Hello boys and girls, today I would like to bring to you the last session of this chapter, chapter 7.3. 7.3, you can see there is a scissors symbol next to the session number 7.3. It means that this part is a non-foundation part. So you will only see those questions in session B. Because you have to understand is that this part will be relatively more difficult than most of the questions you can see in chapter 7.1 and 2. So this part only appears in session B. But I would like to say is that this part of question, you will easily see them in MC question, that means in paper 2. Because usually, okay, for the last few questions, especially the last 5 questions, there may be one question asking you about the intersection between a straight line and a circle. So you should pay more attention to it. And in this session, actually, as the title said, it's talking about the relation between a line, a straight line, and the circle. So the first point you need to learn is the points of intersection. So you know that circle and a straight line only you have 3 cases, because circle is in quadratic form, x squared or together with y squared. So for square equation, when it is combined with a straight line, which is only degree 1. So when you combine it, you should have the equation combined with still in degree 2 in quadratic. So you know that for quadratic equation, you have only two solutions. That means that for a straight line and a circle, even you don't have the graph you can see in this page, you should know that there should be only at most 2 solutions. You may have less than 2, but at most 2, okay, because it's in quadratic. So you can see that in general, it's just like the quadratic function, because quadratic function is talking about a line and a quadratic curve, and for circle, it is also a kind of quadratic curve. So you have similar property is that you can have 2 intersection points, or only 1, or you have no intersection point, just like you can see A, B, and C here. But do remember, in order to check, okay, whether it is individual the case, so what you need to do, you can see that the board will show you using the method, just like what you did in quadratic function, is that you substitute the functions to the other. But do remember is that now you can see the straight line should be in linear form, which is in degree 1. So we will say that we always say you have to put this into the circle instead of putting the circle into the straight line, because you cannot say x squared can be reduced to x or y, but x, y can be put inside the x squared, y squared, and then you do further simplification. So you can see in general there are so many symbols here, but I don't want to go through those symbols because those symbols are very, very long. The most important thing is that after you have substituted the straight line equation to the circle equation, you should have eliminated one variable. For example, you may just keep x or y. So that equation will become quadratic, so you can use discriminant that you learned before. So please remember is that we use discriminant again to check whether there are how many solutions. Just like before, greater than 0 you have 2, equal to 0 you have 1, and then less than 0 you have no solution, no real solution, just like before. Okay? But do remember is that when we go back to the cases that we are talking about, the intersection between a circle and a line. So for 2 points, it's just a general case. For low points of intersection, it just means that the line and the circle are separated. They never intersect. But do remember this case. If you have only 1 point, so we will say it should touch, the line touch the circle. Then we should remember that this one, if you still remember, we will call it the tangent to the circle that you learned in Form 4. So I will talk about this one more in the next clip, maybe next supplementary clip using Cantonese. But I just want to say is that this one would be also one of the cases that you may have to consider. Okay, now we go to see some examples talking about points and intersection, besides of using discriminant. So you can see the example 15 brings you that now you have a straight line and the circle equation, and we say whether they intersect. So in order to check, it's very easy. Just substitute the line into the circle, and then you simplify until you have only one variable, no matter x and y. So do remember is that for your example, you can see that it makes y a subject and then you eliminate the y after you substitute. But actually, you may also write the x as subject in here. For example, we say x equals to negative y minus x. Similarly, then you can also put negative y minus x into the equation here to eliminate the x. So no matter the equation is in x or in y, just check the discriminant as usual to see whether it should be greater than 0, equal to 0, less than 0 to determine how many points of intersection are there. That means that no matter you make x or y subject, you just do as usual using discriminant. Okay? Now, so you can see here, you check discriminant, you can see it's less than 0, so you say it do not intersect, just like before. And for example 16, it's just similar. Now, this time I gives you the condition that intersect at 2 points. So what you need to do is just substitute again, and this time you will have to leave your unknown constant k into the equation, but still use a discriminant to set the discriminant greater than 0 for intersecting 2 points. So you can just write the range of k, just use a equality sign, as you can see before. And then for the part B, it's talking about the coordinate points of intersection. That means that if you know that, okay, the circle and the line intersect, so what are the points of intersection? So just very easy, as I just said. This time, you don't need to do any inequality because you have to find the intersection. So you just put the two equations together and solve for x and y. So this one, very easy. So I just keep it, okay, because just talking about the line and the circle, there are two equations. So you just substitute the line to the circle. Always remember, sub the line to the circle instead of substituting the circle to the line. This is one of the points you need to remember. And then the last part is talking about the tangents to the circle. As I just said, I will give you more explanation in another clip, supplementary clip, other than this one. But here, I would just like to bring to you that what the books want to tell you. If now I want to talk about the equation, okay, equation of tangents to the circle. So what you need to remember is that now we have to find the equation of the tangent to the circle. But before you have to find the equation, you may have to get some geometric property about the tangent. Is that if I have a circle, okay, and if I say now you have a line which is called a tangent, so you should have only one contact point. Because when we talk about tangent, you should have only one contact point to the circle, and we will call this one is the tangent. And besides of this, then if you still remember, there should be also one important geometric property about tangent to circle. We will say that if I mark the center of the circle, you join these 2 points together, so this line should have the right angle formed with the tangent. And this one is a very common property you learned in Form 4. It is called tangent perpendicular to the radius. So this one is also very helpful for us to find the equation of tangent, because once you have right angle, okay, so you will have the relation of the slope of the two lines, for example, the green line with the tangent slope equals to -1, which is one important property for perpendicular lines and slope. So keep in mind this concept, and this concept may be very helpful for you to do the questions further on. So let's take a look on example 19. In example 19, you can see now I said Ch.7.3 is a center and A35 is exactly the contact point. Now you have to find that L. So in order to find that L, the tangent, so you can see the book will show you a very easy way. So first of all, you can see it joins AG, that means it joins the radius. So you know that, as I just mentioned, you have the property of right angle. So what you need to do, you can first of all to find the slope of AG. Then you use -1 divide the slope of AG, you get the what? You get the slope of L. And because you have got the slope, okay, which is this one, and the point already, so combine these two, you will have the point slope form that you can get the equation of tangent very easily. So please remember, the most important thing is this one. If you are given a contact point of the tangent and the circle, and also you have the center of the circle, then you can very easy to find the equation of the tangent because you can just find the slope of radius. Negative 1 over it, you will get the tangent slope. You get tangent slope and the given point, then you can find the equation of tangent very, very easily. Okay, so this is one easy example that you will see here. Another example is that, okay, you will have unknown variable, unknown constant, okay, unknown numbers in the equation of tangent. For example, this time I say now I have the equation of tangent which is called y equals to x plus c, but we don't know what to say. That means that we don't know the y-intercept of this line, so we don't know. But we just say that this line, when it contacts to a long circle, for example, x minus 4 squared plus y squared equals 18, this known, all the things known. We know that it is a tangent. So in order to find the last unknown constant c, in order to know the equation of tangent, so what you need to do is just you have to recall what we said before is that tangent means one contact point. One contact point means discriminant equals 0. So you can see the ball will follow what it wants to tell you is that you use discriminant equals 0. Because for tangent, you have only one contact point, so you will have discriminant equals 0. But you have to prepare that when you substitute the equation to the circle, especially with some unknown number here, your equation will become a little bit complicated because your equation may have square of the unknown constant because you have to put it into the something into the circle which we have the x squared, y squared, and so on. So you can see at this time the equation you have got is not easy to see, is a little bit complicated, but don't worry, still use this equation to have discriminant equal to 0. So once you use discriminant equal to 0 here, the x or y should be eliminated because discriminant would not use the variable, but will use only the coefficients of the equation. So you can see at this time, your equation will only in terms of c only. Then you can find c because in the whole equation, you will not have x, y after you state the discriminant. You just have some coefficients and unknown constant coefficients, just like here is a c. So you can see that it brings you to another quadratic equation in C because this equation is to find C. For example, here you can see c squared plus xc minus 20 equals 0. This equation is after you have called the discriminant, you can find C. But originally, the equation of what you substituted would be the one underlined with yellow. But do remember they are different. Okay? Now, so do remember is that the most direct way is to use discriminant, even you have unknown constant. So besides of this one, you can also see the example 21 is also like this, is that you have the equation of tangent, which is called y equals to m1x. So why do I know this is tangent? Because you can see the keyword here, touches. So when we say touches here, it means that the line we are talking about should be the tangent to the circle because when we say touches. And so you can see in order to do this, okay, even you do A or B, you just do as usual is that you put it back and then substitute the L, the line to the circle, and then what you need to do is just to simplify. But once again, you may see the things will be a little bit complicated because it's quite long here. And this time I would like to skip the part B because part B is just what? So this one is just a application problem. So I think that you can read by yourself. But don't worry, if you don't understand, I will take the time to take a supplementary clip and let you see later. But now, I would just like to bring you some exercise before I end this session. So you can see there are many questions here, but I'll just skip it. So now, I would like you to try to do this 5 or 6 questions. Question 7, 9, 11, 19, 23, and 25 is optional because 23 and 25 are very similar, but quite long because these two questions are both talking about there is unknown constant in the tangent to the circle. So you have to substitute to the circle and then use discriminant equals 0 to find that unknown constant. Quite long, so I think that you may just do either one of the questions. 25 is longer, so I say 25 is optional. This time the due date will not be on Wednesday or tomorrow. I set the due date on Thursday because I would like to integrate all classwork that I assigned you to do before, and I would like to explain all the classwork or select some important classwork to explain to you on coming Friday, which is the 28th of February. Okay. I think that tomorrow morning I may take the supplementary clip more about equation of tangent to circle. Okay, and I will also give you some trick that some tutorial center teaches you, because those tricks are actually comes from additional mathematics in past C exam syllabus. But I think that they may be a little bit useful for you to solve those problems about a line and a circle. So today, up to here. Thank you very much and keep healthy day. Goodbye.